In previous video, we have discussed about how to form PDE by eliminating arbitrary function, only one arbitrary function. So for that, what the process is very simple. Here we need to go for partial differentiation. But what we have did is, in case of one arbitrary function, if only f is there, so the first order partial derivative is enough to eliminate one function. But when it comes to two arbitrary functions f and g, you need to go for second order partial differentiation. So let us understand through this example, which was given in 2009 VTU exams. Form PDE by eliminating arbitrary functions f and g from z equal to f of x plus ay plus g of x minus ay. So whatever the given equation is there, take this as equation number 1. So now if in case of two arbitrary functions, you need to go for second order differentiation, partial differentiation. So now if you differentiate z with respect to x, so which is denoted by notation zx, so derivative is f differentiation f dash of x plus ay. With respect to x plus ay, derivative is 1 plus g differentiation g dash of x minus ay. With respect to x minus ay, 1. So in the same way, let us go for zy, first order differentiation with respect to y. So f differentiation with respect to I, so it will be f dash of x minus x plus ay into a plus g differentiation g dash x minus ay into minus a. With respect to x minus ay, minus a. So now if you go for first order derivatives can eliminate only one arbitrary function, not both. So first order differentiation is, partial differentiation is not enough to eliminate both functions. So that's why what we need to do is, let us go for second order differentiation. zxx means whatever the zx is there, differentiate with respect to x. So f dash, differentiation of f dash, so f double dash x plus ay plus g dash differentiation g double dash x minus ay with respect to x minus ay, 1. So let us take this as equation number 2. So now zy we have, go for zyy means second derivative, differentiate zy. So f dash differentiation, it will be f double dash x plus ay. With respect to x plus y, another a. So already a is there, so it will be a square plus g dash differentiation, so g double dash x minus ay into another minus a into minus a square, that is a square. So now a square is common here, so take a square common. So if you take a square common, we get f double dash x plus ay plus g double dash x minus ay, that is zyy equal to, but we know f double dash plus g double dash is zxx, so substitute here. So a square zxx, so zyy equal to this. So we know the notations. So a square zxx means r, this is t notation. So t equal to a square r is the required PDE, where it has no arbitrary functions f and g. In the same way, you can try for another problem. Z form PDE by eliminating arbitrary functions from z equal to f of x plus at plus g of x minus at. So this was given in January 2017 examination. So here also what we need to do is, it is same as the given problem, but instead of x and y, here we have x and t. So just go for differentiation with respect to x twice, then with respect to t twice. So if you differentiate, then for this problem you are going to get the answer as ZTT equal to a square ZXX. So this is the answer you will get. You try yourself this problem. Now let us solve another problem. Form PDE by eliminating arbitrary functions f and g from phi and psi from z equal to phi of x plus iy plus psi of x minus iy, where I equal to square root of -1. So now it is same as previous problem. Consider the given term z equal to phi of x plus iy plus psi of x minus iy as equation number 1. Take this as 1. So here z is expressed in terms of two variables x and y. So whatever the z is there, differentiate with respect to x, with respect to y. So when it is having two arbitrary functions, go for second order partial differentiation. So let us go for zx. This differentiate with respect to x. So phi differentiation, phi dash x plus iy with respect to x plus iy 1. Psi dash x minus iy with respect to x minus iy 1. So now z xx, differentiate with respect to x another time. So now phi dash differentiation, phi double dash x plus iy plus psi dash differentiation, psi double dash x minus iy. So this is z xx. Take this as equation number 2. So now zy with respect to y. So phi differentiation, phi dash x plus iy, but with respect to x plus iy. So differentiation with respect to y. So multiple of y is I. So that we need to multiply. X is constant. So psi differentiation, psi dash x minus iy. So as the differentiation with respect to y, multiple of y is minus I. So that you multiply. So zyy. So phi dash differentiation another time. So it will be phi double dash x plus iy into another I. So I square we get, plus psi dash differentiation, psi double dash x minus iy into another minus I. So that is minus I square. So I square minus I square is also I square. So I square common, I square common. So we get phi double dash x plus iy plus psi double dash x minus iy. So but we know phi double dash plus psi double dash, that is zxx. So and I square, I is square root of -1, I is square root of -1, then I square is -1. So -1 into bracket zxx. So zyy equal to this. So minus zxx, take this side. So zxx plus zyy, that is equal to 0. So this is the required PDE, or in terms of notation. So zxx notation r, zyy t, r plus t equal to 0. This is the required PDE. So let us solve another problem which was given in exams VTU 2008. So the question is, form PDE by eliminating arbitrary functions from z equal to f of y plus 2x plus g of y minus 3x. So take this as equation number 1, given equation. So from here in this problem we need to eliminate f and g. So for that, if you look at arbitrary functions, f and g, two arbitrary functions. If two, you need to go for second order partial differentiation. So first differentiate with respect to x, with respect to y, one time and second time. So zx, f differentiation, f dash y plus 2x with respect to y plus 2x into 2, g differentiation g dash y minus 3x into minus 3. So that is zx. So zy with respect to y. So f differentiation, f dash y plus 2x, g differentiation g dash y minus 3x. This is first order. Next you go for second order, zxx. So differentiate with respect to x again. Zx differentiate with respect to x partially. F dash differentiation, f double dash y plus 2x into another 2, already 1 2 is there, so 4 g dash differentiation g double dash y minus 3x into another minus 3, so minus 3 into 3 means 9. Next zy, differentiate another time, zyy you will get, so that is f dash differentiation f double dash y plus 2x with respect to y plus 2x 1, so g dash differentiation g double dash y minus 3x. This is what we got. But if you look at these two equations, both are same, so from these two relations you can eliminate one function, not both. So for that sake you go for zxy, so means zx differentiate with respect to y, so this is f dash zx differentiate now with respect to y, this one, that is zxy. So f dash differentiation f double dash y plus 2x into 2, now plus g dash differentiation g double dash y minus 3x into minus 3 already it is there. So now consider these three, 2 equation 3 4, consider 2 3 4. From this you need to find out, you need to eliminate f and g. So let us consider first and third. So here 4 f double dash 9 g double dash is there. So what you can do is, so here if you take 2 9 g double dash minus 3 g double dash, so if you multiply equation 4 by 3 it will be minus 9, so when you add it will be 0. So now 2 plus 3 times 3, 2 plus 3 times 3, 2 equation 2, that is zxx plus 4 zxx equal to 4 f double dash plus 9 g double dash, equation 4 multiply by 3, so 3 times zxy is equal to, multiply by 3 here, 2 into 3 6 f double dash minus 9 g double dash. So when you add both, 9 g double dash minus 9 g double dash get cancels, so zxx plus 3 zxy equal to 4 plus 6 10 f double dash you will get. Take this as equation number 5. Now so f double dash we got, so here also what you can do is, using 3 and 4 eliminate again g. So here minus 3, here equation 3 just plus 1 g double dash, so multiply by 3 and add both, so 3 multiply equation 3 by 3 and add to 4, so 3 zyy equal to 3 f double dash 3 g double dash, and this one zxy equal to 2 f double dash minus 3 g double dash. So here 3 g double dash minus 3 g double dash, that will get cancelled, so 3 zyy plus zxy equal to 5 f double dash. So take this as equation number 6. Now refer equation 5 and 6. So is it possible to eliminate f from these two? Here 10 f double dash, here 5 f double dash. So if you multiply this by 2 it will become 10 and subtract. So what we can do is, so equation 5 minus 2 times equation 6. So if you consider that one, so what we get, so 5 zxx plus 3 zxy equal to 10 f double dash, equation 6 multiply by 2, so 6 zyy plus 2 zxy equal to 10 f double dash. So here subtract it. So if you subtract it, so what we get, so this side minus minus minus, so f double dash minus 10 f double dash, so that will get cancelled. So zxx 3zxy minus 2zxy plus zxy, you will get minus 6zyy equal to 0. So this is what we get. So now what you can do is, so zxx notation is notation for this zxx r plus s minus 6t equal to 0. So this is the required PDE which we got after eliminating arbitrary functions. So in the similar way you can try for this one, z equal to f of x plus 2y plus g of x minus 3y. So question is, form PDE by eliminating f and g from this. So let us solve another problem. Form PDE by eliminating arbitrary functions from z equal to y f of x plus x g of y, which was given in exam for 7 marks in the VTU examination July 2018. So what you can do is, consider the equation as it is, z equal to y f of x plus x g of y. Take this as equation number 1. So now if you look at this equation, it is having two arbitrary functions f and g. So it means you need to go for up to second order differentiation, partial differentiation. So now first differentiate with respect to x, so that is zx. So if you take zx, y constant or other variable, f differentiation f dash x, so x differentiation 1, so into g of y constant. So now in the same way you go for with respect to y, differentiate with respect to y partially. So y differentiation 1 into f of x plus x as it is, g differentiation g dash y. So this is zy. Now in the same way you go for higher order, but if you look at this f dash g dash, only it is having f dash g dash and f and g. So from this we can go for zxy. So zxy, what we get, differentiate x zx with respect to y, this one with respect to y. So derivative of y1 f dash x plus g of y differentiation g dash y. So this is what we got, f dash plus g dash. So look at this, zx is having f dash, zy is having g dash, but multiple is y here, multiple is x. So cross multiply. So zx multiply by x, zy multiply by y, so you will get z dash plus j dash. So consider x zx plus y zy. So multiply zx by x, so y f dash x plus g of y plus y into zy multiply by y, so f of x, y into f of x plus x into g dash y. So multiply inside, so x y f dash x plus x g of y plus y f of x plus xy g dash y. So now we have two terms, xy terms, take common, so xy into bracket f dash x plus g dash y plus x y f of x plus x g of y. So like this we got another term. So now xy, f dash plus z dash means zxy, it is zxy plus y f of x, x g of y, y f of x, x g of y is z, so that is z. So this is what we got the answer, x zx plus y zy equal to this, or in terms of partial derivatives, x dou z by dou x y dou z by dou I equal to xy dou square z by dou x dou I plus z. So this is the required PDE. Now let us solve another problem, that is form PDE by eliminating f and g from, that is z equal to f of x plus e raised to I g of x. So this was given in VTU 2013 exams. So now what we can do is differentiate. It has two arbitrary functions, f and g. If two arbitrary functions, you need to go for first order as well as second order partial differentiation. So zx, so z differentiate with respect to x, so f differentiation f dash x plus e raised to I, g differentiation g dash x. So this is zx. Then zy, z differentiate with respect to I, so this term will vanish. So other variable term constant, derivative is 0, so f differentiation 0, e raised to I, derivative e raised to I into g of x, multiple as it is. Now zxx, whatever zx you got, differentiate with respect to x again. So f dash differentiation f double dash x plus e raised to I, constant multiple, g dash differentiation g double dash x. Now zyy differentiation, so zyy is zy differentiation, again differentiate, so e raised to I differentiation e raised to I g of x multiple as it is. So now look at from this zy. So if you take this one as some 1, this one as 2, so zy is e raised to I g of x, zyy is e raised to I g of x. So from this we can understand final conclusion that zy is equal to, from 192, zy equal to zyy, or dou z by dou y is equal to dou square z by dou y square. So this is the PDE which we have obtained by eliminating arbitrary functions f and g. Another problem, that is z equal to f1x into f2y. So here in this problem we have two arbitrary functions f1 and f2. So if two arbitrary functions are there, so you need to go for partial differentiation up to second order. So now zx, differentiate with respect to x, so zx will be f1 differentiation f1 dash x into f2 is constant f2y as it is. So zy, differentiate with respect to y, so that will be f1y, f1x will be constant, so y differentiation f2y differentiation f2 dash y. So now f1 then you go for zxy, differentiate with respect to y, zx with respect to y, so zx is this, so f1 dash x, f2y differentiation f2 dash y. So if you take this as 1, this as 2, and this one as 3, so if you take 1 2 3, so here from this what we can understand here is f1 f2, f1 dash f2 dash we have, that is zxy, and f1 f2 is this z. So consider, so in this problem what we can do is consider zx into zy. So zx into zy means f1 dash x into f2y into f1 x into f2 dash y here. So if you take this one, f1 dash, it can be written as f1 dash x f2 dash x y, f2 dash y into f1 x into f2 y. So rewrite it, these two terms, separate it. So f1 dash into f2 dash, that is zxy, zxy. f1 into f2 is, that is z into z. So zx into zy equal to this, or dou z by dou x into dou z by dou I, that is equal to z into dou square z by dou x dou I. So this is what we got the required PDE after eliminating F1 and F2. Further, you can try these 4 problems, and always remember, problems are different, not difficult, and every problem has its own solution. And for the easy method, you can watch the videos in my channel Math Made Easy. All the best. God bless you.